so much for sparing the time to join us here today at Data Center Live. Let's start off with some really quick introductions, 4 panelists and lots to get through. Lonnie, just tell us a bit about you and your role at Jabil.
Yes, good afternoon, everyone. So my role within Jabil is as a Senior Director for Supply Chain Services, centered here in Europe. And principally what we do is we offer the management of complicated supply chains to a series of blue chip customers. And we do that on a 24/7, 365 basis. So I'm interested today in terms of the debate with the gentleman on my side here, so looking forward to it.
Jean-Francois, or I think JF, you want to go by today?
Yeah, you can go by JF. So I'm JF, I'm the Chief Technology Officer of a data center company called GreenScale. We're building data centers with sustainability at the heart. I come from 3 years at Microsoft before that, where I launched a ChatGPT platform, and 10 years at Amazon.
Nice.
Alex, over to you.
That's me. My role at NTT is sort of the intersect of strategy, commercial programs, execution, operational discipline. How we begin and manage our global organization to execute at scale is challenging, and that's my role with the team.
And Jamie, seems like you're miles away from me right now.
No problem. So I'm Jamie. I've been in the data center industry for about 10 years now across AWS, Stack Infrastructure, and now Iron Mountain. Not me, that photo, but it's an improvement on me. We're really focused on building out EU data center capacity for Iron Mountain at the moment, considering new regions and heavy focus on AI.
Fantastic. Well, let's go right into it. Let's kick us off with this. How is AI fundamentally breaking the old rules of data center design? Alex, I'll come to you on this one.
Well, we were at NTT a collection of different regional operations, operating 10, 20 megawatt data centers. That was great. Suddenly AI has come along, the speculative build has changed. Cloud has changed our business completely. Each reference design, each data center, each operating model per region evolved in different ways. Putting that together under a cohesive global standard still hasn't been completed to a certain extent because we're putting together incredible designs. But here we've got now the AI demand and the demand cycle is that we're faced with the challenges of customers who want 500, a gig site. What do we do? How do we execute? How do we take this on? So this strategic operational change and global harmonization is to actually keep pace with the customer demand. I mean, the digital infrastructure we build is for them, and we need to operate it in a certain way. But the rules have been rewritten and continue to be written every 3 months.
Jamie, there's site acquisition in your title, but from a design perspective, can you shed any more light on that?
Yeah, so where you're focusing on cloud regions for the past decade or so, everyone knows we've been fairly restricted to kind of 30, 40 kilometer radiuses from customer AZs. That's been very challenging, not only for land and kind of power acquisition. And over the last few years, our world has been kind of opened up, and we're now looking at things 150 kilometers from a metro that we never would have dreamed of being able to go and acquire and develop for customers. So from a site selection perspective, it's not only the location, but the requirements are different. You get access to be closer to HV, just from an overall ability for speed to market for that capacity. You're now in a slightly different game, which is really interesting. I think the risk that comes with that great opportunity is that the life cycle of that data center, from an investment management perspective, is much smaller. So most kind of business cases are focused on 2 cycles of chip life cycles. So 4 to 5 years times 2. That's where we need to make our returns in. If you're in a metro, you can look at 20 years. And you can just continue to reuse that data center for multiple different use cases. And it's a much longer asset for us. So it's changing the dynamic of the business cases, the design, and the site selection itself.
I got a point of view on that.
JF, I'll come to you.
So if you go back in 2012, right, when we start the cloud at Amazon, the obsession was the network. Where's the network? How can I connect the site to the network? Because We want it to be close to the end user and the customer base. Then you fast forward to about 5 years ago, right, when AI shows up, and it's all about where's the power? I need power now. I think that the way site selection is going to change moving forward is we're going to go where you have permission to build. We're going to live in a permission first. We welcome first in this area, otherwise you're going to be in trouble.
Lonnie, I don't want to leave you out at all. I want to bring the next question in your direction, with it being a little bit more supply chain themed, actually. AI is clearly evolving, and within that AI, chips are evolving at seemingly breakneck pace. But historically, it's taken us, more like years, 2-3 years, to build a data center facility. So how do we approach building a supply chain that doesn't deliver obsolete infrastructure on that opening day?
Interesting point. If you look at the world of procurement and supply chain, typically organizations are focused on efficiency, they're focused on price, and within this new environment of AI, the need for orchestration across the whole environment becomes paramount. It's the speed to realize the capacity, which is what's driving the industry, and how quickly you can switch that on. You only have to look at some of the key shortages. Energy is number one. Number two, when you look at the semiconductor industry, 50% of that industry now is being structured around memory. And it's high density memory which is driving capacity utilization. You go beyond that, you start looking at the industrial equipment that's required at a site level. Lead times in that environment are anywhere up to 2-3 years long. JP's just touched on legislation and the need to be able to go into an environment which is welcoming from a government point of view and from a regulatory point of view. So it's not too long before you get to a place where joining up the dots is paramount. And it's not price and it's not efficiency. It's a collaboration across that whole supply network, end to end, which is paramount in this game. It's the only way in which the supply will match the demand, because demand at the moment is outstripping supply on all levels, creating the shortages that we see just now.
Mm-hmm. Alex, anything you would add there on those supply chain headaches?
No, I don't think so, because I think Lonnie's the supply chain guy here. All I'd add is that there's lots of conversations about power. What I've heard today is power plus supply chain, the constraints of our business at the moment. But I also think you need to look internally as well at your own organization to be able to execute. The sensitivities between how you build, how you hand over to operations, the point at which customers can take and move into the property, the point of monetization, the point of future divestment, winding it all the way back to the structure of the design and the choice of the commercial customer you take it on board. So yeah, power and supply chain are massive constraints for our business, but how we evolve as data center operators and global businesses is just as important to examine.
Mm-hmm. JF, we spoke, didn't we, backstage just very briefly before coming on about inference. We often talk about AI as this one sort of big bucket almost, but strategically, how does the design of a facility for training differ from one for inference?
So it's interesting, right? About a year and a half ago, everybody thought, well, we trained the model, now we need to have AI inference close to the end user. And for a minute, I bought into this. I thought we were going to see all those edge site data centers close to the end user. In reality, it never materialized, right? Data centers are big fridges. They're very efficient. If you start to put them everywhere, it doesn't really work. The models break down. So what we saw is inference being built on the same subnet than training. I think the big problem, right, is if you go back to an AZ, an availability zone, a data center that's by an hyperscaler, so commercial cloud, you'd build that, finance it for 15, 20 years, change the hardware maybe once, and then you're done, right? And then it turns into a fairly lucrative model in the last few years. We're not building things that as a hardware lives, what, 3, potentially 5 years? So you have to look at the data center in terms of Legos, if that makes sense, right? What can you break down into components that at some point you yank to put something else, right? And all the impact on the financing with that, but that's another story. So you have to build something that's really agile on a platform, a GPU that you have no idea what's going to look like in a year or two. Mm-hmm. And that's the problem, right? By the end of this conversation, a Rubin might be even 10% more capacity. Who knows?
Jamie, I think you wanted to come in there.
Yeah, so difference between kind of inferencing and ML training. If you're standing inside the data center, you're going to struggle to see the difference. They're both likely high density, liquid cooled, heavily connected inside. The difference is when you stand outside and the inferencing is indistinguishable from compute and storage from a cloud computing perspective for latency. Inferencing is below 1 millisecond from a latency perspective. You're going to be in the metro. You're going to be 30-kilometer radius out from the metro. ML training, you're up to 20 milliseconds of latency typically, and you can be 150 kilometers from a metro. So it's when you stand outside the data center that you really see the major differences in them. But inside, they're both high density, both liquid cooled, pushing way beyond 60 kilowatts a position, and past 100 kilowatts. Most of that isn't really in the EU yet. Like we're mainly seeing liquid cooled racks starting about 60 kilowatts coming in from the end of this year. A big lag behind the US, to be perfectly honest. But it's really when you stand outside, you see the difference.
Absolutely. One here that I sort of hope I can get you all to chime in on, the net zero conversation. We're seeing a lot of utilities keep fossil fuel plants open just to meet that AI demand. But how can we reconcile that sort of AI gold rush with the industry's net zero commitments? Lonnie, it's a big question. I'll come to you first if you don't mind.
A short answer at a personal level is there's too much money in play, okay? The long answer is, I think that's why we're seeing so much intervention on the regulatory and the governmental. There's moratoriums where countries are either resisting or prescribing the way in which it needs to be landed into their particular region. So there'll be a series of haves and have-nots. And I think it's still playing out at the moment. We're seeing it in Europe, the UK, and various other places like the Middle East, where it could become highly regulated in order to be able to get to that objective, not only in terms of protecting the national interests, but secondly in terms of hitting the buttons that are in play with whatever political administration's in force. So that's some of the views, personally and professionally.
But what's the alternative, right? I mean, look, data centers are big fridges, and they're super efficient. So if you don't like it, fine. Let's go back to the model where you have a computer room in your building. It's going to be everywhere. It's going to be super inefficient. We're not going to have control on electricity and demand because we don't know what's going to look like. So there's a need to get a little bit of our high horse in terms of how much power a data center is using. They're extremely efficient data centers. That's the ideal way to house compute and GPUs. And just generally speaking, we as an industry are doing a terrible job at educating. Just put it this way. A data center uses less water than 14 golf courses. We don't talk about this, right? Sorry, I got ahead of the next question, but I was on my soapbox.
We are going to absolutely come on to water. I know you're keen to discuss that, JF. But Alex, just on that net zero conversation?
I think it's just a responsibility, not just a topic. We take it very seriously at GDC. So we're proud of the fact that our net zero targets are staged. So our ambition and the work that we're already doing is to be net zero within our data centers by 2030, within our offices by 35, and with our supply chain, arguably the toughest opportunity by 2040. So as NTT globally, we have a responsibility in the way we operate our data centers, and I'm proud that we're actually moving on that as best we can. Is it controllable always? No. Is the AI demand going to challenge all of this continually? Maybe we need to rethink, perhaps. but at least it's part of our mantra, it's part of our values. It's not just a sustainability consideration, it's an economic consideration as well. It underpins commercial deals and also our values as a business.
Jamie, finally, your thoughts?
Yeah, it's just compromise. So that's the only word that you can have when you consider net zero. So you can compromise and you can try to add some type of reduction method onto your gas generation if you're burning gas for your electrons, or you pay twice for power and you're both progressing in parallel your TSO connection that may take 10 to 15 years, whilst also doubly paying for gas generation. There's not really much kind of in between. You can start to mix it more with DSO power as it becomes available and start to dilute your overall microgrid so it's more and more onto the grid as the years go by. But it's all compromises how hard you're willing to kind of decarbonize what you have, really.
Absolutely. Jay, I think your moment's come. We're going to talk water. So, I mean, when it comes to that public discourse surrounding data centers, water, I should say, often is it looms large in the conversation. So, how do we solve that growing tension? You're probably not going to have the silver bullet to this, but how do we solve the growing tension between data center growth and local community water needs?
So it's a PR problem, right? Data center fixed the water utilization years ago, right? Look, anybody in this room who has a car does not stop the car every 20 miles to put more water in the engine to cool off the engine. Why? Because you have a closed loop system to cool your engine. That's what we do in data centers, and we've done this for years. I think it really is about educating people. Again, right? Just do the math, right? 14 golf courses uses more water than one data center. We don't talk about this, right? On the flip side, what's in a data center contributes to the economy. So there's a bit of a catch-22 here. And as I said all the time, as an industry, we need to get better at educating people what's inside a data center. I worked for large hyperscalers in the past. We would never say what's inside because it was our IP, because we didn't want to get our knowledge stolen. I think the model has flipped now, right? Hyperscalers welcome customers and at time press members to look at what's inside a data center. And you'll find those facilities to be extremely efficient, a lot more efficient than having point capacity everywhere in a city.
Jamie, can I throw that your way?
From a water perspective, I completely agree that I think it's a technical challenge that has been long overcome with water storage systems, like on-campus storage systems, no longer focusing purely on municipal supplies and more private water supplies and grey water harvesting. I genuinely think it's a problem. I completely agree with JF. I think it's one of those myths that are out there in the industry. Just like there's loads of other myths, like you can put a ML training center anywhere you like, that we've busted those myths. Everything has its limitations. So I do genuinely believe it's one of those kind of scare-mongering items, and anyone that is in the large-scale campus business knows that it isn't a design problem anymore for us.
Mm-hmm. I want to talk agility as well. It's maybe a slightly sort of overused word, I would say, maybe in the sector. But Alex, to keep up with that unpredictable AI growth, do we need to stop building those monolithic data centers and move to a more almost modular Lego-style construction model?
Potentially. Optionality depends on your business model, depends on your client segment, depends on what you want to achieve. The desire to get bigger, to build bigger, to service clients of different magnitude and capability comes down to the conditions of your capital capability, and what worked for you before, what your P&L produce, private equity investment, or for NTT Data, the larger Japanese entity, that provided enough capital for us to build in the way that we did. Now, with the pressures from our great customers and hyperscalers, we need to build something of a different magnitude, a different size and diversity that, looking ahead, we need to actually rework how we divest our data centers. Recently opened up with the Singapore S3, 6 data centers producing a decent yield for which we can reinvest. But it brings different responsibilities. We had ownership of our organization, the way we run it. If you bring in different partners to produce and build different data centers, you have different levels of responsibility and accountability to people and institutions that you've never had before. So The demand cycle changes your approach to capital, your segmentation, and also takes your focus away from other parts of your business work, which may be highly contributive to operating income in your P&L. These larger scale data centers are a different level of responsibility and risk and a different yield. So just think really carefully about your optionality when moving forward and what your core business is. Just because you can doesn't mean you always should.
Absolutely. And Lonnie, your thoughts on that, and maybe what supply chain challenges that Lego-style construction might bring?
The backbone exists today to be able to support either large scale or micro solution. I think it's really, how do you join up all the dots? You have a heavy reliance on a select few numbers of organizations that are delivering key components today. So resilience becomes a massive part of the equation. How do you add more in terms of alternative sources? How do you break down from maybe only sourcing from one country to being able to localize? All of those factors start to play in. And I don't think there's any one prescribed solution yet, and I think it's still evolving. You know, you look at what's just happened in the last, 12 weeks? Many of you will be aware that, the Strait of Hormuz is a problem, right? And whether they can keep it open or not, that's still up for debate. But a lot of the people in the room here might not understand that 40% of the world's helium comes out of Qatar. Now, that particular substance is fundamental to the production of high-value semiconductor devices.
Yep.
If you don't have the helium, then how do you produce the high-density memory, the high-speed processing, and then the knock-on effect to the other industries, automotive, healthcare? All of those industries are pitching for finite sets of resources in key components that today are all under strain with regards to what's happening in the AI industry. So I think, is it centralized? Is it disaggregated into a smaller solution? I think the bigger question is, how do you get the whole ecosystem to go left or right? That, to me, I think, is the principal challenge.
JF, anything to add there?
Repeat the question again.
So we were discussing the keeping up with unpredictable AI growth, and really the need to perhaps stop building those more monolithic data centers and move into a more modular model.
Fine. You didn't say flexibility, but optionality is what you said, right? I think the key word is, I hate the word flexibility, but because I have opinions, but flexibility is what we're going to have, right? We at GreenScale, we literally look at every component of the data center and what can we literally legalize, if that's a word, and if it's not, I just made it up. That's what we have to do. Because honestly, we don't know what GTC is going to bring next year. And we're back to the drawing board, right? I hear of effort across the hyperscalers to normalize some form of data center, because if you go one way, and then suddenly you have another customers, you got to go and you're back to Reba 2. So these are the things that we need to think about, how you create two-way doors, not one-way doors. And it's hard. It's hard. Every 6 months, I'm like, okay, this is going to slow down. And it's not slowing down, right? And Europe is so far behind the United States, it's not even funny. So yeah, we need to really think about how we can create options, flexibility, and optionality was a great word.
And Jamie, some final thoughts from you?
There's like 3 different types of builds, really. You've got your traditional stick built, which no one is really doing anymore because it doesn't make sense. You have prefabricated, where things are coming in on skids and they're in pods and it's highly fungible and flexible. Then you have modular, which is essentially the least flexible of all data center types. and certainly isn't much use for speculative builds. It needs to be driven from the customer down for modular. Where there's the most opportunity is really in the prefabricated space, and that is really where everyone is going for their European reference design. I don't think anyone has stick-built as a standard reference design. It's all coming in parts and pieces. Most of the labor is attributable not to the site, and it's in the factory where it's created. And you're coming in at commissioning stage, kind of level 3, 4, and beyond, and you're really connecting the pieces together. And it allows you in those pods to make changes closer to RFS. Not close, but closer than it would have been elsewhere. So I think the only kind of fungible thing you can really do at the moment is go and outline plan a data center to an envelope that you know will work from a prefabricated perspective that allows you to change the pods later on. That's the only way to really catch this technology shift at the moment. There's not many other ways of doing it.
Now we're motoring through these. We're sort of drawing towards the end of our conversation. I want to pose you one, I think probably fair to say, pretty big question to kind of draw things to a close. So as AI efficiencies increase, history suggests maybe we won't use less power, but we will just do more computing. So Lonnie, I'll come to you first. Are we actually capable of building enough power to satisfy what is really the exponential appetite of AI?
Interesting. Let me look at it from a UK point of view, first of all. The UK can generate more electricity than it ever needs. The problem is not generating the power. The problem is getting it from point A to point B. We've got legacy infrastructure, cables overhead in the ground, which are past their due date, and quite frankly, the infrastructure won't allow that to happen. So if I look at this country as a whole, there is massive amounts of money going into that network upgrading that's taking place just now nationally. But I think maybe a distributed power solution becomes potentially one way of doing it. I think it's uniquely different from country to country. Some countries are leapfrogging generations of infrastructure and going straight to an end point. Other countries are choosing different solutions, whether it be nuclear or other methods of generating. I think at a UK level, for example, we can generate the power. The problem is we can't get it to the place where it needs to be.
Mm-hmm. Who's leading the way? Just some insight there. You mentioned the countries that are maybe doing the leapfrogging.
Well, the Netherlands are doing, big guns in terms of AI and the support for it. You've got regulatory controls. The Middle East, they don't want the data going offshore, so they're going to put the investment in to have it locally and regionalized. Obviously, the US goes without saying. That's the predominant technology driver on the planet as a country. So for them, it's a huge economic growth factor. I think those would be the ones that come to mind with me at the moment. And unfortunately, the UK isn't one of them.
Mm-hmm. Absolutely. JF?
Isn't that funny, though, the Netherlands, the country that was one of the first to put a data center moratorium 5 years ago, right? So then you see the economy, and then suddenly they change their mind. The one thing that you forgot is permitting.
Yep.
Right? I mean, so I'm French, you can tell, but I lived for 30 years in the United States until I moved to London last year and a half ago. The permitting in Europe is a freaking nightmare, right? And the rules and the regulation, and if you're on that side of the fence, you can do this. If you're on that side of the fence, you can do that. You go to Texas, you do a hole in the ground, you add gas, you power generation. Boom, done. So that's the other problem, right? The UK is totally capable of catching up, right? Yep. France artificially reduced the cost of power to attract more AI companies, right? It's all about who wants to win and what it takes to win. But if you focus on the data center is not the problem. I don't believe it is.
Alex, coming down to you.
So the question's about whether we'd find enough power to service what we need. Probably. As humans, we're quite innovative at finding problems to solutions. I think there's a range of solutions there. It's whether they're palatable to the environments they're in. We're growing technology hugely fast. As humans and humanitarianly, perhaps not so much. That's a different debate. But I do believe that the choices that are actually available are there, but it may push it into other areas. So you might see data center growth and builds going to other regions who accept different types of power sources, and there's been great presentations on them today, as acceptable. Who will not retreat into NIMBYism around nuclear when it's required, yet we require it for GDP and growth. We don't have digital divide with our communities and cultures and our working people of tomorrow because they don't have access to AI, which unlocks everything that they can learn. So there will be a way, but we might have to make a trade of choices and what's acceptable.
Mm-hmm. And Jamie, we'll finish with you.
Yeah, so I think if you asked every hyperscale CEO, like, what's your demand for AI, they'll probably tell you that they have an unfulfilled demand of 10 gigawatts or more each, right, that cannot be fulfilled. But the reality of building even a gigawatt campus at the moment is unfathomable unless you've been there and seen how big it is. JF is building a few hundred megawatts in the Nordics, and just the reality of 200 megawatts, there's no hotels that can fit that many labor sources. Like, you're building hotel pods to go with 200 megawatts. So imagine if you then go to gigawatts. So I think it's no major issue that we're not able to meet the demand. I think we need a bit of a natural kind of slow just for reality, to be honest, is one kind of element of it. But we're seeing this massive shift to inferencing. So on average, rule of thumb, you deliver 100 megawatts of ML training capacity, it will generate 15 megawatts of inferencing closer into the metro. And that's really started now. Like, it's going to be exponential in kind of 3 to 4 years' time, when most of the bigger campuses have done all of their sorting out and training of the data, and now people need to make some money off of that. So I think it's just a slightly different focus. I think we're all going to be talking about getting back to the metros soon, and we'll be back to building 20 megawatt data centers, anything we can to serve this inferencing latency sensitive demand. So I think just understand we're not in a bubble necessarily. we're in a version of a bubble which I don't think will pop, but it will just get to a natural point where it will flatten. AI, ML is basically like a holiday home, right? There's only so many times you can go and visit your holiday home. Eventually you need to go and make some money in inferencing. So I think we are starting to see us heading towards that way, and more focus is going back to the metros.
I'm sure everyone's pretty keen to get away sharpish for our upcoming networking drinks, but we do just have a couple of minutes for some audience questions. So if we do have any questions, can we get our mic out to our audience members? The lady just here in the red jacket. I'm not sure where our roaming mic is at the moment. There it comes. Just a lady. Can you keep your hand up high, please? Thank you. The lady in the red jacket just in the middle.
Doreen, I'm sorry to keep asking questions, but this one is on water. And Jean-Francois and Jamie, I'd really like to hear your thoughts on it, because what you say is that there isn't a shortage of water. And I'm very curious to understand why you say so, given the pushbacks we're seeing in the United States, but also because we are seeing new companies develop cooling solutions. For example, liquid cooling that's not using water. So are those companies going down the wrong road and creating something for nothing?
And if I may ask, which industry you're from?
Financing. So my job is to get the financing for the data centers and the nuclear power plants.
So I didn't say there's no shortage of water, right? I said data centers don't use waters that community don't have access to, right? A data center, if you get an NVIDIA hardware shipped to your place, it's to your data center, it's shipped with some gas in it, and they look if the gas pressure is still around. If it's still around, that means that the loop inside is correct. There won't be any water leak. You do put water or some liquid cooling in it first, and then it's a chilled loop, right? It's a closed loop. The days of evaporative coolings and the days where we use water for data centers, that ship sailed, 5, 6, 7 years ago. Right? We do use closed loop now, and you may put some water originally, but there is no there's no data center that is using water at the expense of a community. That's just not true.
Okay.
But somebody has a statistic and want to prove me right or wrong, I'd like to see that. I've been a data center business. I was the third in the existing infrastructure team at Amazon when a data center was mainly for the retail side, right? So I've seen the entire evolution of racks. At the time, that was 10K per rack, and I've never heard. I hear that a lot, right? I hear this argument a lot. Jason Alexander, the guy who was in Seinfeld, was on a TV show a couple of weeks ago saying a data center uses 800 gallons of water per hour. I'm like, where's that coming from? Right? These are it's high attention statistic, but I'd like to be proven wrong. So one of them probably Colorado, but Colorado has been sending water to California for years now. Has nothing to do with data centers, right? The drought in Colorado started over a decade ago, and because a lot of that water has been redirected to other communities, right? Most people in California get water from the Colorado River. Maybe you're referring to Maine, who just put a moratorium on data centers, but those are not...
Georgia, Utah, and you're right, Colorado.
Okay. I'd like to see, I understand what has been said. I'd like to see the supporting data. I understand that, right? When I tell you that a data center uses less power than 14 golf courses, I probably made that on the spot, but I'm pretty sure I'm right.
It's really interesting stuff. I think we've got time for just one more question. I think actually the next hand I saw was just over here. Thank you, guys.
So you spoke around the UK having enough energy to support, AI and the growth in data centers. And then you mentioned transmission constraints, and then even if you go to like Octopus Energy's website, you can see how much money we're wasting on curtailing wind energy, renewables. Is there anything that the data center industry can do to access that energy, given the grid constraints and given sort of the balancing issues?
Who
can tackle that?
I mean, yeah, you can always build closer to the generation source itself. It comes with other challenges as well by building close to a generation source, in that you're not building where there are general contractors available. So you are bringing those general contractors up into a location that most likely isn't heavily populated at the moment. So from a kind of business case perspective, it always sounds very simple to say, I've got this generation in Scotland or whatever, I'm just picking a random location. There's 500 megawatts that's just burning off every single year, can't be used, go and plug a data center in. But the economics of that data center is very challenging when you're trying to introduce a major construction project into an area that isn't populated, and you're basically bringing London GCs up to Scotland, and it does start to break from an investment perspective on returns. But the concept is to plug data centers in closer to the generation assets, as close as you possibly can, to reduce exactly what was described around. We definitely have enough generation. I don't think anyone would say there's an issue with the amount of electrons that are in our overall capacity in the UK. It's just so strenuous to build that route down to where we actually need that power, and so convoluted. A 14-kilometer route would easily take 3 to 4 years without even thinking about it, with thousands of easements, and that's just one small data center. So kind of then take that to the gigawatt scale, it just gets more and more complicated.
If I may, right, we spend, ironically, Jimmy and I were at Amazon at the same time, different teams, but we spend a lot of time building the intelligence for site selection at GreenScale. So as I said, right, you go back 12 years ago, it was the network. 5 years ago, it's the power and rights, the permitting and permission to come. We cannot build this entire algorithm, right? And I agree with you, right? Going to build next to the power generation source is difficult. We found a gem in Northern Ireland where we have quite a bit of access to offshore wind. It's going to come, right? It's actually not available. It's being built, but you need to think where you're building, and you need to think a couple of years down the road, because the immediacy of demand forces you to take some bets on locations in 2 to 3 years.
Fantastic. Some great talking points there brought up by our audience. Thank you so much for raising your hands. I'm afraid, though, that is just about all we've got time for from the panel and from day one here at Data Center Live, the London Summit. Thank you so much, first and foremost, to the panelists for joining me. Thanks again to all of you for joining us today, and to our event sponsors, of course, for making this whole thing possible. Thank you.